Hello, good people. Welcome to the fourth video here of section 6.6. When we last left off, we had talked about two properties that were a consequence of defining the definite integral as the area under the curve of a graph. And we were, or I guess we weren't, I had done A and C on property number two. And property number, or example B here, had us switch the limits of integration in order to go from left to right, and that subsequently changed this -4 into a +4. And then we just had to find the definite integral of f of x from -2 to 0 and then multiply it by 4. But when I came over here and I said from -2 to 0, that would be this triangle. Oh, but what's the base is 2, but what's the height? And that was like, what? Well, remember, this segment has a slope of 2/3, right? It goes up, it rises 2, and then it goes over 3. So my slope is 2/3. But what that really means, or not what that really means, but another way to look at it is if the slope is 2/3, that means it goes up 2/3 of the way for every one step it goes over. It goes up 2/3 for every one it goes over. So this point, if I start at -2 over here, if I go 2 steps to the right, that means I'm going up 2/3, which would make this y value 4/3. And therefore, the height of this triangle, the triangle that I'm looking at here, would be 4/3. The base, of course, would be 2. And so if I come back over here and finish this problem from the last video, this would be 4 times 1/2 base times height, and then 1/2 times 2 times 4/3. I think that's just 4/3, which would make this 16/3. So it's not that bad to figure out. It just, at the beginning, it was like, wait, it doesn't fall on an exact point. It falls in between, and it's not halfway. Where is it? Oh, it's at 4/3. Because if you know the slope of the line, you know that it goes up 2/3 for every one it goes over. It goes up 2/3 for every one it goes over. So it actually goes up 4/3. All right, that was the end of property number 2. Property number 3, I feel like it's connected to another property of integrals that we'll talk about later, which is if I'm finding the area of an integrand that has two parts, and by two parts I mean I have a function, f of x, and I have a constant that I'm adding, I can separate them into two different integrals. So I can say this is the same thing as the integral from a to b of the function with respect to x here, plus the integral from a to b of the constant from with respect to x here, dx. And so just like we were able to split up derivatives when we were adding or subtracting, we can split up integrals when we're adding or subtracting, because if integrals are really just areas, then we can find the areas of each little piece and then bring them back together. And so here, knowing that, then property number 3 makes a little bit more sense. Because if c is a constant, let's just do an example. This is why it works, I guess. Let's say I'm taking the integral from 1 to 3 of 4 dx. Well, what is the function, what does that integrand 4 look like? This is just, it's not even dotted, it's just a horizontal line at 4, right? That's what the function looks like. But I'm looking for the integral between 1 and 3. So if I look at the integral between 1 and 3, that's just a rectangle. And that rectangle has a height of 4, and it has a width or a base of 2. And I know that's 2 because it's really just 3 minus 1, right? That would be this distance, 3 minus 1, and then this height is just 4. So what this is telling us is whenever I have a function plus a constant, I'll do the integral of the function the way we've been doing it, which is this part. But to find the integral of a constant, we're really just finding the area of a rectangle where c is the height, the constant is the height, and then the base is just the distance between b and a. And that's it. So let's see, what do we know? We know that the integral from 1 to 4 from 1 to 4, we know this integral is 4.5. How do we know this? It's given to us. What we want to know is, what's the integral between 1 and 4 of f of x plus 5? Well, again, if we follow this rule, the rule says this is the same thing as the integral from 1 to 4 of f of x dx plus the integral from 1 to 4 of 5 dx. This part was given to us, 4.5. This part is just a rectangle whose height is 5 and whose base is 4 minus 1, or 3. So therefore, this is 3 times 5 is 15. So that's 19.5 would be the final answer. That's it. Same thing with letter B. Same thing with letter C. I'm not going to do letter B because it's kind of like letter A. But letter C, if you'll look, I have to worry about a couple of things. First, I got to worry about the fact that my limits of integration are upside down. So I'm going to flip them, but that means my answer is going to be the opposite. So it's going to be this minus, and then I'm going to flip them, which means it's going to be plus 3 dx. Do you see what I did there? I flipped the limits of integration as I was splitting the integral apart into two pieces, but that meant I am taking the opposite of what would have come out of there anyway. And then here, there's this 2. I can take it out, so that's really negative 2 times the integral of 1 to 4 f of x dx, which, by the way, we know is given to us as 4.5. So then this is really negative 2 times 4.5. Let me put this in brackets instead of parentheses. Doesn't matter. Plus the integral from 1 to 4 of 3 dx. Well, that's a rectangle whose height is 3 and whose base is 4 minus 1. And together, that would give me 9. And then this is negative 9, because if you multiply negative 2 times 4.5, oh, so then this is just going to equal 0. So property number 3 says, if you're taking the integral of a function plus a constant, take the integral of the function and add it onto the area of a rectangle, because a constant in the integrand represents a horizontal line, and a horizontal line will create a rectangle shading whose area you can find pretty easily by doing this right here. And that's what that represents. And then finally, this one should make perfect sense. If you know that we have 3 x values, a, b, and c, in that order from smallest value to largest value, if I'm looking for the area or the integral of f of x from a to c, and I know b is in between them, then I can take the integral from a to b and take the integral from b to c and then add them together, right? This is just telling us that if you go from a to b and find this area, and then go b to c and find this area, then you can add them together to get from a to c. Like it should make some sense, right? Can you find these integrals given the information about the integrals from 0 to 10 and from 4 to 10? Okay. Can you find the integral from 0 to 4? Well, let's visualize what's going on here. From 0 to 10, my integral is 6. What does the function look like? I have no idea what the function looks like, but it's 16. And I know from 4 to 10, from 4 to 10, it's negative 4, right? So maybe this graph doesn't look like this. Maybe it looks like, I don't know, something like that. So the total is 16 from here to here. And then this area right here is negative 4 from 4 to 10. So the question is, how much is it from 0 to 14? Well, I'm sorry, 0 to 14, 0 to 4. Well, the formula says that the whole integral is equal to the integral from 0 to 4 plus the integral from 4 to 10. And we have two of these three integrals already given to us. You know, the answer is 16. We don't know how much this is, but we do know how much this is, and it happens to be minus 4. So if you just add that over, you're going to get 20. This is more work than you need to show. You can probably mentally do the calculation without having to show everything. I'm just showing you where it comes from. By using this property, I can figure out what that first piece is. Same thing with letter B. Letter B, these are upside down. So I'm going to say it's the opposite of the integral from 0 to 4. While I'm here, I might as well put the 3 out because it's a constant. So the integral from 4 to 0 of 3gx dx is the same thing as the opposite of 3, or negative 3, of the integral from 0 to 4 of g of x dx. Oh, but we figured out the integral from 0 to 4 in part A. So then really this is just negative 3 times 20, and that would be negative 60. Done. And then finally, for letter C, this is really property number 3 that we just talked about. Take the integral from 4 to 10 of g of x dx, minus the integral from 4 to 10 of 5 dx. You can also say plus negative 5 if you'd like. I just wrote minus 5. This first part we already know is 20. The second part is just a rectangle because I have a constant function. So height times base. And so that's going to be 20 minus 30, and that would be negative 10. If you think about it, the other way to approach these graphically is to say, I'm looking for the integral of this function, but what are we doing to the function? According to transformations, we're shifting it down 5 units. So if we're going to shift it down, chances are we're going to get a negative accumulation, right? Because it's shifting down. But that's property number 4, and that's the end of the properties and the end of 6.6.